this is new homework for automata class, and we will make a Turing machine for this language. So, is there anything that I can say for Turing machines? Turing machines are deterministic automaton, and they don't accept a lambda transition. Is there anything else? They can move to right or left, it doesn't matter. If you remember in the other automaton like DFA or DFA or some others, we cannot move to left, but in Turing machine we can move to left. Okay, let's start. I'm gonna draw all the Turing machine with pencil. Let's start from Q0. Also, I want to write 0, 1, 2, 0, 0, 1, 1, 2, 2. Let's continue from this two string, okay? In Q0, first we need to read a 0. And for 0, 1, and 2, let's say for 0 I want to make it x, for 1 I want to make it y, and for 2 I want to make it z. You can use ABC or something else, it doesn't matter. I just want to make it something different, okay? So I'm doing it as x and move to right. Last thing, I'm in Q1 now. I'm in the 1 now. So in Q1 I need to read 1. I need to read 1. So 1. I want to make it y and continue to go to right. But there is some other options. For example, if I read x, if I read 0, make it x, and there is 1 more 0, so I need to make a transition also for that 0. So if I see 1 more 0, leave it like 0, because in this language we need to revert these numbers like finding the leftmost one. So I will make it x, I will make it y, I will make it z, and then go back to Q0, come here, find the leftmost 0, I will make it x, I will make it y, I will make it z, and then I will go to accept state. So we are making the leftmost ones like the different letters. So for this 0, I'm not doing anything, I'm leaving like just 0, and go to right for reaching the leftmost one, okay? And then I read y and continue. Also, let's think about, I made it x, I made it y, I made it z, and then go to Q0, I made it x, and now after making x 0 to x, I read 1 more x. Is there any point like that? No, because if I want to continue to y, all x's must be all zeros must be x, okay? If I want to reach this one, I need it's already could be x, so I can read a y here. I mean I made it x, I made it y, I made it z, and then I made it x. Now I could read a y, so I need to make a transition for y. If I read y, I'm not changing anything here, leave it like y, and continue to go to right to reach this one. Okay, now we are in the Q2. In Q2, we made this one as y. We are here now, we are in 2, so I want to make this 2 to z. I write it like, okay, I want to make it z and continue to go to right, but I think because of after reading a 2, I need to check something, if this 2 is the last one, or I need to go back to the loop. So let's go to left for last letter. For if I read Z, I'm gonna go to left. Go left. We are in Q3 now. Okay. So here, let's think like I read this second two, and I go to left. I need to read this two again. So I will make a loop here for Q2. No, not here. Sorry, here. Because after reading these two, I'm here. After reading these two, I'm here and in the Q3 point. Okay. So here, if I read again 2, leave it like 2 and continue to go to left. If I read a 1, leave it like 1 and continue to go to left. Or there's one more or two more ways. If I read a Z, continue to go to left, leave it like Z and continue to go to left, or Y, leave it like Y and continue to go to left. So I will continue to go to left in point Q3 until I reach a 0 or a X. If I see a X, it doesn't mean anything. I need to reach the X, so I will write X2. If I read a X, leave it like X and continue to go to left. And then if I reach an X, I'm going back to Q1. If you read an X, leave it like X and start to find second leftmost letter in your string. So go to right. Okay, we are here. For example, X 0, Y 1, Z 2. Where are we? We made this 2Z here, and we started to go to left. We read 1. Still we are in Q3 and go to left. We are Y, go to left. We are 0, go to left. We are X. Now we are here. Read X, start to go to right. Now in Q0, we are in 0. What are we doing? We are making the leftmost 0 again, X. So we are making this loop again until all of the leftmost letters are done. And there is nothing like 0, 1 or 2. The whole string becomes X, Y and Z. Okay, so we made all the string like X, Y, Y, Z and Z. What happens? Here we made 2Z, go to left, and we read Y's, go to left, and we read X, go to right. We are in this Y now in Q0. What are we going to do? If we read a Y, this means all string becomes fully X, Y and Z. So we can go to except state from Q0. We don't need to make this loop again. So if you read a Y, leave it like Y. We are not changing anything now. And continue to go to right. Okay, continue to go to right. In Q4. So there could be 2 or any more Y's. So we need to finish reading all Y's. If you're still reading Y, leave Y's like Y and continue to go to right. We read that Y, now we are in Z. What are we going to do? If you read Z, let's say Q5, after finishing reading Y's, we are in Z, leave Z like that, no change here, and then we need to finish reading all Z's. If you read Z, leave z, sorry, if you read z, leave z like z and continue to read from right. And if you reach the last z, as you know, Turing machine tapes are infinite, yeah. There are always a letter, or let's make a symbol for the infinite tape continues like that, okay? So there is x, x, y, y, and z, z, and we reach the end of the string. So what are we going to do? If you reach the end of the string, make something. What can I do? I can accept this string now. So in Q6, which is our accepting state, in this state we are accepting the string. What we read this set already in Q5. We are in the diamond shape now. If you read diamond shape, leave diamond shape as diamond shape and go to right or left, doesn't matter. Let's say left, or you can write right, no problem, and accept the string. Yeah, this is my drawing for Turing machine that accepts zeros, ones and twos. Thanks for watching.